Hi, welcome to this online sessions, digital classes. Okay, so we are seeing so many patterns in our daily life situations, correct? For example, if I say 2, 5, 8, 11, 14, what is the next number? If I ask it to you, then you will think about it. 2, 5, 8, 11 means each number, the successive number is increased by 3 units. So you may think that is when it is 14, what is the next number? It may be 17, correct? Or for example, this year I am giving 10,000 rupees to you. Next year I am going to give 500 rupees extra to you, means 10,500. Next year to the next year, so 500 may be increased 11,000 rupees. Like we can give some daily life situations also, correct? And if you see our nature, when you take the sunflower, the petal, if you observe the petal of the sunflower, so there are so many concentric circles if you observe it. In each petal, so the number of seeds increase by a constant number if you observe it. Okay, we will see so many things here, so many patterns. So if there's a pattern with a specific things, such patterns are said to be progressions, sequence, series, all these things, correct? So today we are going to learn the concept of progressions, which is highly useful for our daily life situations also. Okay. So before going to that, see this example. We see a lot of pattern in our daily lives. For example, Rohan's salary in his first year is 2,000 and he will be getting increment of 500 per year. So his salary for the first, second, third, fourth will be of the form 2,000, 2,500, 3,000, 3,500 like. So here we see the pattern in the Rohan salary. The difference between two consecutive year salaries is constant. In the similar world around us, present us, these patterns are many-form. Just now I said. Okay, if you observe it, the salary per annum is of course annum, particular annum 2,000, next year 2,500, next year 3,000, next year 3,500. Means his salary increases with a constant amount, that is 500 rupees, correct? Okay, in this chapter we will learn a special type of pattern, call it as arithmetic progression. Actually, we have 4 kinds of progressions in our syllabi, not present state syllabus text in general and standard. That is arithmetic progressions, geometric progressions, harmonic progressions, and arithmetic geometric progressions. But in present syllabus, we are going to learn only 2 kinds of progressions. One is arithmetic progression, other one is geometric progression. So in the chapter, we are going to learn a special pattern called as arithmetic progression. Okay, just see the pyramid-like patterns. We are seeing so many pyramid-like patterns where objects are increasing or decreasing. The height, just if you see the pyramid from top to bottom or bottom to top, so the layers are increasing by or layers are decreasing in a particular way, in a constant manner. Just observe this stadium. Here there is a stadium, correct? Cricket stadium. Now, of course, students are fond of seeing cricket. So they are seeing the cricket through TV channels, but they enjoy to see the cricket match in stadiums only. When you observe the galleries, different galleries, if you see the different galleries, see here, this is one gallery, this is another gallery, like. So the seats, rows, when you see the rows, if you observe the rows, so the seats in each row are decreasing by 4 from the previous row. When you take it from top to both seats in each row decreases by 4. Or you observe it? So when you make it in such a pattern, then only it seems to be very beautiful. Clear? Okay. So one more interesting thing here. Situations involving diving in the ocean could be used as well as, did you know that a diver should descending a rate no faster than 66 feet per minute or ascending at a rate of no more than 30 feet per minute. See, observe this diver. So if you see that this diver, so when he enter into the sea in deep way, so he increases his speed at the rate of 66 feet per minute, or decreases. Okay, so here maybe decreases, maybe increases. Generally, if you see, he decreases his speed 66 feet per minute or increases at the rate of 30 feet per minute. This is a common process. So why? There is a reason. There is a reason. So I'm sure many students don't know why, and this could be certainly create some great accountable time. So we will discuss it later, but if you also just think it, I am giving a thought-provoking question to you. Why the diver? Just he increases the speed at the rate of 66 feet per minute or decreases, okay, at the rate of 30 feet per minute. So just observe it. Okay. Now coming to this, these are the different live examples which are used in daily life situation. Clear? Okay. So now coming to our concept, arithmetic progression is a sequence of numbers in order in which the difference of any two consecutive numbers is a constant value. Okay. For example, the series of natural numbers, if you take it as 1, 2, 3, 4, 5, 6, and so on. It's an AP. It's an arithmetic progression. Why? This, if you see, which has a common difference between two successive terms. When you take 1 and 2, these are two successive terms. 3 and 4, two successive terms. 4 and 5, two successive terms, and equal to 1, because the difference of two successive terms is 1. 5 minus 4 is 1. 6 minus 5 is 1. Even in the case of odd numbers, odd or even numbers. So even numbers 2, 4, 6, 8, 10. So they are increased by 2 units. If you take odd numbers 1, 3, 5, they are increased by 2 units. Is it correct? Clear? See here, the common difference between two successive terms is equal to 2. If you observe in our regular lives, we come across arithmetic progression quite often, correct? For example, roll number of students in a class, days in a week or months in a year. This pattern of series and sequence has been generalized in the mathematics as progressions. Okay. So now coming to the arithmetic progression, there are so many definitions are available. I will give just 3 definitions. Meaning is same, but presentation is a little bit of different. Definition 1, if you see it, a mathematical sequence in which the difference between two consecutive terms is always a constant, it is abbreviated as AP, arithmetic progression. If the two consecutive terms difference is constant, such progression is said to be an arithmetic progression. Now coming to the definition 2. So an arithmetic sequence or a progression is defined as a sequence of numbers in which for every pair of consecutive terms, the second term or second number is obtained by adding a fixed number to the first one, is called arithmetic progression. Just will generate the next number by adding something or subtracting something throughout the series. Now definition 3. The fixed number that must be added to any term of an AP to get the next term is known as a common difference of the AP. Take difference of any two consecutive numbers or two consecutive terms, that will be considered as a common difference. Let us consider 1, 4, 7, 10, 13, 16 and so on. The common difference is here 4 minus 1 is 3 or 7 minus 4 is 3. So the common difference is 3. Okay. Let us consider the following series. 1, 5, 9, 13, 17 and so on. So if you see this, 5 minus 1 is 4, 9 minus 5 is 4, 13 minus 9 is 4, 17 minus 13 is 4. A common difference is there. If you consider the second set, 1, 2, 3, 4, 5 and so on. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. Okay. Now when you consider 7, 7, 7, 7, so it's not an arithmetic progression. In the common difference, there is no increasing or no decreasing. So it is not a arithmetic progression. Is it clear? Here the difference between any two successive terms is constant. Such series are called arithmetic progression. Okay. Now some very important points about arithmetic progression. The difference is called the common difference of the AP and it is denoted by D. The members are called terms. Here the members are called. The first member means the first number, a first term is called first term. We can denote the common difference by D. If you consider A1, A2, A3, A4, A5 and so on are in AP, then the common difference D is A2 minus A1, which is equal to A3 minus A2, which is equal to A4 minus A3, which is equal to A5 minus A4. We can represent the general form of an AP in the form of A plus D, A plus 2D, A plus 3D, A plus 4D and so on. Is it clear? Where A is the first term and D is the common difference. In the AP series, okay, if the AP series, if you consider a arithmetic progression series, okay, has last term, then it is a finite arithmetic progression, and if the AP series has infinite, then it's called infinite arithmetic progression. If it is a finite series, we call it as a finite series. If it is a more infinite, it will call it infinite series. Okay. Now describing the arithmetic progression. If you want to describe the arithmetic progression, very important terminology is initial term or the first term. In an arithmetic, the first number is in the series is called initial term or the first term. Generally, we represent it with A. The common difference, the value by which consecutive terms increases or decreases is called the common difference. Generally, we represent the common difference as with D. Okay. The following sequence, just observe the 0, 5, 15, 20, 25 and so on. So here, it's a arithmetic progression. The common difference is 5. Is it clear? Okay. Now, the AP can be also written in the form of common difference as follows as A plus D, A plus 2D, A plus 3D, A plus 4D, A plus n minus 1 into D. Now observe it here, A1 is equal to A plus 1 minus 1 of D. A2, second term D, that is A plus 2 minus 1 into D. A3, A plus 2D, that is A plus 3 minus 1 into D. Where AN, A plus n minus 1 into D. Here A plus n minus 1 into D is said to be general form of nth term. Where A is the first term, D is the common difference, n is the number of terms, where An is the nth term. Clear? This is a formula. Generally, we can observe it. Okay. Now, I'm taking an example and I will have to explain the required problem. So, 1, 2, 3, 4, 5 and so on En, the number of terms are 15. Okay. Find the nth term of the series simply. What is the nth term of the series? Okay. AP 1, 2, 3, 4, 5 and An. So, n is equal to 15. We are using the formula An equal to A plus n minus 1 of D. Here A is 1 and D is 1. So, nth term An is equal to 1. Simply we can say n. Now, find the value of n where A equal to 10, D equal to 5 and An is equal to 95. So, you have to find the which term is 95. So, A equal to 10, D equal to 5 and the nth term is 95. By using the formula, An is equal to A plus n minus 1 of D. So, when you substitute the value 95 equal 10 plus n minus 1 into 5, when you simplify it, you will get n equal to 18. Okay, now find the 20th term for the given AP 3, 5, 7, 9. So, here A is equal to 3 and D equal to 5 minus 3, 2, n equal to 20. So, An is equal to simply A plus n minus 1 of D, that is A20 equal to 3 plus 20 minus 1 of 2, that is 3 plus 38, which is equal to 41. Clear? So, some more problems here. Find the problem following formulas using the progression, 10th term of the arithmetic progression, you have to find it. Okay, I've just